before we continue today's class, okay, first, I mean, we have like the fifth quiz today, okay, which will be given out like near the end of today's lecture, okay. So that's the first thing, and the second thing is那个 sample final 贴上去了吗？No. Okay, the sample final has been posted on the E-class. Okay, so in case you haven't checked out, I mean, take a look, just to get an idea like what the final looks like. Of course, the problem will be different. Okay, but at least you get a look at feel of like what I'm going to give you for the final. Okay, and which day is the final? 期末考试是几号 ？December 17th. Okay, December 17th. Today is the last lecture of November. Is that right? Yeah, today is the last lecture of November, so we still have like, let me see. We still have like 1, 2, yeah. Before the final exam, we still have 2 lectures. So in other words, we will have the 6th quiz, okay, which will be given out like just a week prior to the final. Okay, so yeah, I guess like the only one that will not be covered by the quiz will be just 1 lecture. Okay, so I think that's I hope that can help you prepare for the final exam. Okay. So come back to this one. Okay. So first, we need to concentrate on the relationship, on this process. We need to concentrate on the relationship of VI and the UI. Okay. Remember, VI comes from the column vectors. VI are the column vectors. Okay. Of a given, matrix. And the UI will be after you after you go through the process, the UI will be orthonormal basis. Okay. So if you really like pay attention to this process, I told you, okay, basically, you just try to represent. Here, of course, eventually you want to convert to UI in this process. But so you write this formula backward, okay, try to represent VI by UI. You will naturally get the QR compensation. Okay. let's just write the first few terms. The V1, okay, because W1 is V1, right? So U1 is W1 divided by the known W1. So basically, you can say V1 is, you know, the known of W1, which is also U1, V1, which is also V1, okay, times U1, right? Right? There shouldn't be any question about that, right? You just multiply the denominator to the other side. That's it. So then, so this is at that side. I think I told you this is okay. Typo here. So how about like B2? B2 can be represented as W2 times U1, right? W2 equal to W2 known times but W2 is not E2. Okay. W2 actually is the B2 minus that, right? So it's going to be B2 minus B2 dot U1. Okay. U1. So if we know this, then we can represent B2 W2. Okay. And W2 will be W2 no dot right? 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 Okay, if you try to write B2, you know, with the UI and actually you can also represent, of course you can represent this one, you know, as anything, okay, but because the norm of WI is a scatter, right? So let's just keep that scatter, okay? I mean, we could replace WI with the VI as well, but it's going to make like the formula more complicated. Let's just keep it that way. And then you try to write more terms. These three. It's going to be okay. B3 W1. basically this part plus this one. These three U2. Okay, and then the last one. Right? Right? Okay. You can keep writing down. Okay. Okay. But I think that 3 terms should be enough for you to see inside the the rules. Okay. 就是你写3个 term， 大概就可以看得出来它的就是怎么讲，它的那个规律哦。Okay, so in our work, okay, if this is E1, E2, E and okay, these are the column vectors. Okay, then you will write it as your U1, U2, U1 is column vectors multiplied by. I mean, let's try to see the connection. Okay. This one will appear in the first term, right? And all the other are 0. Okay. If you try to multiply, this one with this is actually n by n. Okay, n by n. This is n by n. But you will see the first one, if you keep the first one, W1 known, all the other 2 is 0. Okay, then multiply this with this one. Okay, the first column will be E1, right? Right? And then, okay, because you are going to, be able to construct E2 by U1, U2, right? E2 by U1, U2. So this one will appear here. This is the E2, U1. E2, W1. And the second term will be W2 long. And all the others will be 0. Right? Right? Okay. And then the third one will be, these 3 dot U1 and these 3 dot U2 and then the normal dot U3 and then all the 0. Because you are able to construct the E3 by U1, U2, and U3. Right? Okay. So we will obviously see that this is upper triangle. If you present this as Q, and then this one is R, then first Q in Q, all the column vectors, they are orthogonal. not only orthogonal, they are orthonormal. Okay, they are orthonormal. Okay, and R will be upper triangle. You know, square matrix. I mean, that actually is what we have here. And your Rij basically is what we are talking about. So basically, the whole this decomposition represents the Green scheme, like the orthonormalization process. Okay. So, and just like what I said, like you just represent like di by all those ui's, and you can understand this decomposition. So, having said that, let's have a look. As I said, okay, these three will be orthonormalization, like the orthonormal vectors you obtain from these three column vectors. Okay, and the first one, obviously, you just divide it by its norm. Okay, so that's why it's 1, 2, 2, 4. This is also, the ratio is 1, 2, 2, 4. And also, you need to divide by its norm, so you can compute the norm of this one, which is, by the way, W1 norm, which appears in the diagonal. Okay, I mean, so it's 5. You can compute it by yourself. And then, once you have that, okay, the second one, okay, you need to, this one will be the norm. Okay, by the way, okay, because the diagonal elements they represent the norm, so obviously they must be positive. They not only, this is not only upper triangle matrix, the diagonal terms must be positive because the diagonal terms represent the norm. Okay, so basically W2 norm. Okay, so what is W2? W2 is basically B2 minus B2 dot U1. Okay, so B2 is negative. Let's calculate W2. W2 is B2, which is original column vector. -2. 0, -4, 0. This one, W1. Okay. The first one is 8 over 5. So it's negative 10 over 5, so it's negative 2. So this is 2. But it's negative 2, so it's a positive. Okay? And then multiply by u1. So u1 is right? So your W2 is going to be this is your W2. Okay. So you compute the norm of W2. This one. The norm of W2. Okay. So the norm of W2 will appear here. Okay, and then this one, U2W, U2W1, I mean, we calculated that previously already, that's negative. Okay, I will stop here. I mean, the rest of it you can calculate by yourself. So basically, this just represents the Smith, Gram-Smith. This factorization just represents Gram-Smith, like the normalization process. Okay. So that's it. Okay. So this is like what we missed last time. Okay. And section 7 is also Gonal polynomial, which will be skipped. Okay, we're not going to cover this in this class. So, so that's the end of this structure. And then this will bring us to the last structure, eigenvalue. So, first, what is eigenvalue? Here's like what we are going to cover in this class. I was pondering whether or not we should cover section 2, systems of linear differential equations. But it's really not difficult, but if this the section 2 should be covered by